Okay, AP Calculus BC, Unit 3 review, corrective, continuing, doing the last page, separate video. So parametrics, so we have a x formula, for the x position, y position with respect to time. We want to find the velocity vector. So the velocity vector, Vx, is going to be what dx dt is, which is going to be e to the t minus 2. Velocity in the y direction, it's going to be derivative of y with respect to t. So it's going to be 2t. So at time 0, plug 0 in here. Usually use these sharp braces. Plug 0 into x, that'd be e to 0 is 1, minus 2 is negative 1, and 0. That's your velocity vector. The speed at time 0, so speed is the square root of velocity x squared plus velocity y squared. So we're going to do the square root of, we just found them, the velocity in the x direction squared. So we're going to get 1 plus 0 is 1. So that's the speed at time 0. When is Albert flying vertically? So vertically is going to be when the slope is undefined, right? Now the slope comes from dy dt over dx dt. So this is going to be when we get division by 0. So that means that dx dt needs to equal 0. So that's e to the t minus 2 equal to 0. E to the t equals 2. Take the natural log of both sides. And we get t equals natural log of 2. So that's when, when it's going vertically. Concave down, well, that would be the second derivative, which is kind of complicated. So second derivative of y with respect to x. So we take the first derivative, dy dx, and then we take the derivative of it again with respect to x, except it's not written in terms of x. So we take the derivative with respect to t, because that's the variable in it. So it's like implicit differentiation. And then you got to multiply by the derivative of t with respect to x to finish the implicit differentiation. And what we usually do is we write that down here on the bottom, put that down here, but that's why it makes sense. So we need to dy dx, we could write that up here. That's the slope of the curve, which is going to be dy dt over dx dt. And so that's going to be 2t over e to the t minus 2. So when we take the derivative of it, again, we have to do quotient rule. Low d high minus high d low all over low squared. But then you got to divide by dx dt, and that's going to be e to the t minus 2. So that's going to give you breaking up the work. That's going to give you, if we simplify it, you can have 2e to the t minus 4 minus 2t e to the t all over e to the t minus 2 cubed. And we're going to set it equals 0 undefined to find where the concavity might change. And then probably do a line check. Now, the one on the bottom, that's going to be when e to the t minus 2 equals 0. So that's going to be t equals natural log of 2 is a place where we need to put on the number line. And then this other one, we can use our calculator to try and solve this. I don't think we're going to have any luck solving that by hand. So I'm going to go to y equals 2e to the x minus 4 minus 2x e to the x. I'm going to go to the window. We're looking at, I guess it doesn't really tell us where we're looking. So we just start with like negative 10 to 10. We're really just looking for the x-intercepts, maybe. Let's just see what this looks like. Yeah, we're just looking for the x-intercepts. So kind of looks like it doesn't have any. I mean, we can make the window even bigger and see what happens. But it appears to have some sort of like horizontal asymptote here. And then there's something there. We can't see it now because we zoomed so far out. But that's what we saw earlier. It goes up a little bit and then it goes down. So it doesn't look like there's any. So in the graphing calculator, it looks like there are no actual zeros. So we would do a line check with the second derivative natural log of 2. We test a point. Natural log of 2, natural log of 1 is 0. So this should be positive. So if we tested 0, that's over here on this side. And so 0 would give you e to the 0. That's 2 minus 4. That'd be negative 2. Or no, yeah, that'd be negative 2 over negative 2, negative 1 cubed, which would be negative. Should be positive than negative. And so it's concave up, it's concave down. And so we're looking for when it's concave down. So that's going to be natural log of 2 to positive infinity. Now, usually on these problems, we also want to make sure we always use positive time. So we really probably wouldn't even look at anything to the left of 0 anyways. And you don't include the endpoints for concavity. So integral for the arc length. So integral for the arc length. Arc length is like distance. And so distance is the integral of speed. And so that's going to be the integral from 0 to 5 of the square root of vx squared. So it's going to be e to the t minus 2 squared plus 2t squared dt. So that's the integral. And then on your calculator, you could do this. You could do math 9. You do square root of parentheses e to the x minus 2 close parentheses squared plus 4x squared close parentheses comma x comma 0 comma 5. In case I asked you, which I probably could ask you, and the answer is 142.721 units, whatever units they are, round and truncated through decimal accuracy. Part F says, what's the limit as x goes to infinity of f prime of x? So that would be, that'd be the limit of the slope of the function. So that'd be dy dx. And so that would be the limit as x goes to infinity of, so dy dx is that's that. And so if we go to infinity, it's going to be infinity over infinity, indeterminate form, but this is going to blow up. That's a dominant term, so it's going to go to 0. So there we go. All right, and then number 9, similar problem, but with some trig involved. So, again, we could do, dx dt equals 2 cosine t plus 1, and then dy dt equals 1 plus 2 sine t. Okay, so dy dx, which is dy dt over dx dt, is going to be 1 plus 2 sine t over 2 cosine t plus 1. So I'm just getting all that done ready up front. So the velocity vector at 0 is going to be, you're going to plug 0 into this, and so cosine of 0 is 1, so you can get 3, and that's going to be 1. So that's your velocity vector. The speed is going to be the square root of 3 squared plus 1 squared. which is going to be 9 plus 1, which is 10. And then when is Albert flying vertically? Now you got to watch on vertically and horizontally stuff and make sure it's not happening on both of them, which I think this one might. This might happen. So vertically, that's going to be when dy dt is dy dx is undefined, which is dy dt over dx dt. So you got to be getting division by 0. So it's going to be when dx dt equals 0, which is 2 cosine t plus 1. So cosine t equals -1/2. The reference angle is, so cosine is 1/2. Goes from 1, root 3 of 2, root 2 of 2, 1/2. So it's going to be 0 pi over 6, pi over 4, pi over 3. And it's quadrants 2 and 3. So it's going to be t equals quadrant, it's going to be 2 pi over 3 in quadrant 2 and 4 pi over 3 in quadrant 3. But you want to make sure that it's not also horizontal at the same time. So a lot of times you're asked to find both of them. So I'm going to do that up here. I'm going to say, well, when is dy dt equal to 0? And so that's going to be 1 plus 2 sine t equals 0. So sine t equals -1/2. And reference angle is going to be pi over 6. And it's going to be quadrants 3 and 4. So t equals 7 pi over 6 and 11 pi over 6. So we're good. Those don't conflict. If they do, it can't be both at the same time. It might be one, but you would have to do L'Hopital's rule to figure it out on paper. When is it concave down? So we got to do the second derivative. Like I said, second derivative is the derivative of the first derivative, right? So we're going to definitely start with first derivative, and we're going to take the derivative of it. The problem is it's in terms of t. So implicit differentiation says take the derivative with respect to the variable that's there, and then follow it up by the derivative of that variable with respect to the variable that you want. And then we usually put this down here in the bottom. The derivative dy dxt, we got to do quotient of low d high minus high d low all over low squared. But then you still need to divide by dx dt, which is another 2 cosine t plus 1. So our second derivative is, if we clean this up, we get 4 cosine squared t plus 2 cosine t plus 2 sine t, right? Negative gets distributed, and then this does. So it's going to be positive 2 sine t plus 4 sine t squared all over 2 cosine t plus 1 cubed. So this is, that's pretty, on the bottom, cosine t equals -1/2. That's reference angle of pi over 3, quadrants 3 and 2 and 3. So t equals 2 pi over 3 and 4 pi over 3. So we got those. And then we also, we got to solve the top of this. When is that equal to 0? So that's ugly. I don't know if we're going to have much luck doing it. I mean, the sine squared and the cosine squared equal 1. So, I mean, that could be simplified down to 4 plus 2 cosine t plus sine t equals 0. You know, we could divide a 2 out of everything. So, I mean, we can get it kind of simple, but I still think that we are kind of stuck solving this. So I'm going to use my graphing calculator, and I can put the simpler one here, 2 plus cosine x plus sine x. You got to make sure you're in radian mode, which I am. Okay, so then I'm going to go to window, and I don't know, I guess up here they did tell us this time 0 to 2 pi, so I'm going to say 0 to 2 pi. I really just want to see the x-intercepts of this graph, see if it has any. Not quite. So Doesn't have any x-intercepts. So none. But and then we could do a line check, and so we put 2 pi over 3 on here, and 4 pi over 3, and 0 to 2 pi, and test a point. 0 seems like a good point to test. Test equals 0. Into the second derivative. So that's going to be 4, that's going to be 6. Those are going to go 6 over 3 cubed, 6 over 27, which is positive, right? Positive, negative, positive. So concave up, concave down, concave up. And so we're looking for concave down specifically. So that's going to be 2 pi over 3 to 4 pi over 3. Do not include the endpoints for concavity. Increasing, decreasing, we do. So that's where it's concave down. And then integral for the arc length. So arc length is the same as distance along an arc, which is distance traveled, which is the integral of speed, like it was last year with one-dimensional motion. So 0 to 5 of the square root, but speed's calculated differently this time. So this can be 2 cosine t plus 1 squared plus 1 plus 2 sine t squared dt. I need the dt. Okay. So on your calculator, you can do math 9, and you could do a square root of parentheses 2 cosine x plus 1 squared plus parentheses 1 plus 2 sine x squared, close parentheses on the thing, comma x, comma 0, comma 5. This should give us the answer. There it is. 10.897 through decimal accuracy, rounded or truncated. Comes out the same this time. If we were to do the limits, well, let's see. I don't know. I don't think there's. I didn't ask for it, and I don't think it actually has one. So that's it for the corrective. A bunch of good practice for your retest. Make sure you're ready.